I welcome you to the Florida Viktor channel. In today's video, we will see with the help of AI which jobs can be replaced by AI robots. As you can see, even content creators are at risk. We present to you a kitchen robot that can cook independently. A robot suitable for auxiliary tasks in the construction industry. Several types of agricultural robots. Stone slab cutting smart saw. Let's see why the hairdressing robot does not work well. Cleaning robots. Intelligent conductor robot. Warehouse material handling AI robot. And finally, one fake news from the world of AI and table tennis. AI robots in the kitchen are transforming the culinary world by introducing automation and precision. A cooking robot is designed and programmed to perform culinary tasks that usually require human intervention, such as chopping vegetables, stirring ingredients, baking, grilling, ingredient retrieval, and meal preparation. These usually include one or more articulated arms used for their enhanced dexterity, a critical skill set for cooking. Other components include sensors and sometimes even AI-enabled cameras. Software plays a vital role in the functioning of a cooking robot. Some robots can be programmed to follow specific recipes, or they can learn from experience and user feedback to improve over time. Some advanced models are capable of learning new recipes from the internet or adjusting recipes based on dietary preferences or restrictions. Integration with IoT devices. Some models can connect to IoT devices, such as smart fridges, for a fully integrated kitchen system. Restaurants are rapidly adding AI to their front and back of house operations. In essence, a cooking robot embodies the intersection of culinary art and technological advancement, aiming to enhance efficiency, precision, and convenience in the kitchen. First of all, here is a robot that will be able to perform basic support work in the construction industry. Atlas is a humanoid robot developed by Boston Dynamics. It's considered one of the world's most advanced humanoid robots. Atlas has been primarily focused on locomotion, starting with walking in a lab, then walking on various types of unstable terrain, and even performing parkour tricks. Atlas has recently been equipped with proper hands, allowing it to pick up and manipulate objects. Atlas uses depth sensors to generate point clouds of the environment, helping it understand its surroundings. Atlas uses models of its own dynamics to predict how its motion will evolve over time and adjust accordingly. Atlas has been shown attempting construction work, demonstrating its ability to interact with the world in meaningful ways. Atlas is 1.5 meters tall and weighs 89 kilograms. It uses a mixture of titanium and aluminum 3D printed parts to give it the strength-to-weight ratio necessary for leaps and somersaults. Boston Dynamics continues to innovate and push the limits of Atlas, exploring the potential of the humanoid form factor. In mid-2012, for HV100 robots from Harvest Automation achieved an elusive milestone in robotics. The robots were purchased by a customer and began everyday farm work. HV100s, also known as Harvey robots, distribute and collect container-grown plants in greenhouses and on large nursery farms. Since their introduction, more growers have adopted Harveys, and to date, Harvey robots have moved well over 3 million plants. The HV100 is designed to work with and alongside people. It's small, safe, flexible, and can navigate within current infrastructure. Technology. The robot uses an approach called behavior-based robotics. It responds immediately to changes in the work environment, intelligently accounts for imperfect sensory data, and requires little setup and programming. Benefits. The HV100 can increase productivity, efficiency, and plant quality. It addresses labor scarcity issues by performing manual labor, allowing human workers to focus on other tasks. It can also reduce non-labor production costs, including the use of water, pesticides, herbicides, and fertilizers. The sweeper robot is the first sweet pepper harvesting robot in the world demonstrated in a commercial greenhouse. It is designed to operate in a single stem row cropping system, with a crop having non-clustered fruits and little leaf occlusion. The main objective of the sweeper project is to introduce the first generation of greenhouse harvesting robots into the market. Functionality. The robot uses a camera to recognize the color of a pepper and determine if it's ripe for picking. It's designed to operate in a single stem row cropping system. Efficiency. The sweeper robot can identify and harvest ripe vegetables in 24 seconds. However, it currently has a success rate of 62%. Future plans. The researchers are working to make the robot faster, more accurate, and capable of harvesting additional crops. Benefits. The sweeper robot not only increases greenhouse efficiency but also reduces dependence on labor in a continuously stressed labor market. It's expected to enable around-the-clock harvesting and reduce food waste. The Grow Tomato Harvesting Robot is an advanced agricultural technology designed to automate the process of harvesting tomatoes. AI and 3D vision. Grow uses machine learning AI and 3D vision technology to deliver high-resolution color images for successful harvesting and provide detailed crop data for ongoing analysis. Dual robotic arms. The robot has dual robotic arms that can pick both sides of the greenhouse row, making robotic harvesting faster than ever. Smart shears. The smart cutting shear mechanism allows Grow to find the optimum position, make a precise cut, and secure the truss for any tomato crop. Onboard boxing system. Grow transfers picked trusses into standard-sized, reusable packaging containers for seamless integration with existing production processes. Autonomous guided vehicle. Grow's autonomous navigation uses an advanced drive system for fault-free navigation. 24/7 operation. Thanks to built-in wireless comms, Grow is always on and accessible via the cloud, providing real-time data collection and analytics for improved crop management and 24/7 service and support. Labor savings. Grow is the answer to labor shortages in greenhouse horticulture, with the potential for 80% labor savings. Smooth integration. The system does not need greenhouse modification and can be instantly integrated into current operations with existing logistics, packing, and handling system. The Baka Robo Sawjet 2.0 is a robotic stone-cutting saw that was the original robotic-based sawjet introduced to stone fabricators. The Baka Robo Sawjet, a fusion of innovation and precision, is revolutionizing the stone processing industry. Combining the efficiency of a conventional saw with the versatility of abrasive waterjet technology, it effortlessly transforms colossal slabs into intricate masterpieces. Faster speeds. Robo Sawjet comes standard with high-pressure coils on all 6 axes, allowing the robot to move much faster from cut to cut. More productivity. The dual-table Robo Sawjet allows loading and unloading in one station while the robot is cutting in the opposite station. Less cutting time. The Robo Sawjet system uses a 26 HP saw motor equipped with a 16-inch saw blade. The sawjet process eliminates the need to move saw-cut pieces between cuts by finishing cuts with the waterjet. Robo Sawjet can cut faucet holes, arcs, and sink openings, reducing the need to move pieces to secondary stations to complete these cuts. The question of whether AI robots can replace hairdressers is complex and depends on various factors. Technical feasibility. Cutting hair is a precise task that is almost impossible for a robot to do, and regulations prevent robots from using scissors near a person's head. If robots are capable of doing surgery, then the technology is definitely there. However, it simply isn't financially viable to develop the technology to get robots cutting hair. Hairdressing is not just about cutting hair, but also about the human interaction that comes with it. AI will not replace human beings, but will enable human beings to perform their jobs more efficiently by making the business infrastructure more intelligent and reliable. This allows the hairdresser to focus on innovation, creativity, and client service. In conclusion, while AI and robots will likely become more prevalent in many industries, the unique blend of technical skill, creativity, and interpersonal interaction in hairdressing makes it less likely to be fully automated in the near future. Janitor robots, specifically those designed for cleaning toilets, are becoming increasingly sophisticated and offer several advantages. Increased hygiene. These robots can clean toilets more thoroughly and frequently than humans, which can help to prevent the spread of germs and bacteria. Robots are less likely to be injured by hazardous chemicals or sharp objects. These robots can navigate complex office plans, use elevators, and find their own way to each bathroom location in an office without much assistance. The robot is equipped with sensors that pave the way to maneuver spaces, mapping the building's intricacies through video and 3D depth data. The Alta 3 is a humanoid robot that has been used to conduct orchestras. Alta 3 controls the volume and tempo of the music. Limitations. Despite its capabilities, Alta may struggle to completely fulfill the human ability to feel the music. How it works. The premise is that the android itself is moving according to its own will. As a structural program, the structural elements of the score which created is inserted into the independent and autonomous actions. The Squid is a warehouse robot developed by Bionic Hive, an Israeli company. Squid is a fully automated, autonomous robotic solution that picks and replenishes boxes and delivers them anywhere in the facility. Squid robots navigate warehouse floors using inbuilt cameras, learning to recognize and avoid static objects, such as walls and shelves, as well as people and other moving objects. The impact of this is that automation can happen in warehouses without a full overhaul of the entire operation, making it more cost-effective and simpler to implement. With the way that the robots can move vertically and horizontally along pallet racks, the need for warehouse staff to risk their personal safety atop ladders and lifters is effectively eliminated. The Squid is powered by an AI-based algorithmic engine that can sort, select, and put away packages. A video circulated on social media showing a robot playing table tennis against a human. However, this video was not real. It was created using AI visual effects software called Wonder Studio One. The original footage was from the European Championships and featured 2 human players. One of the players was digitally replaced with a computer called Wonder Studio One. The original footage was from the European Championships and featured 2 human players. One of the players was digitally replaced with a computer-generated robot.